This Shepard and Metzler task is among the most famous in all of cognitive psychology. Of all the articles that I've ever cited, or that a lot of people have cited, I bet this ranks in the top 20. It's a fascinating proposition. And here's the task that people were asked to do. If you'll indulge me, I'm going to pull this up. If you could look at, let me scroll just a smidge. Thanks for your patience. The question that participants were asked, and I'm looking here at these white circular figures that are enshrouded in black. Is the right figure the same as the left? And in the first example, I think it is. It's just rotated, as you can see. In the second one down, which is labeled B, it is also. They are the same. But by the time you get to C, I think it's different. They are not the same figure. You could tell just rotating doesn't make a difference there. So that was the participant's job, if you will, to determine that. And figure 9.3 shows the results. This close correspondence between angle of rotation of the two drawings and the participant's reaction time in determining a yes or a no suggests that participants performed the task by mental rotation of one drawing. The more time it took participants to come to a decision was the same for rotations in the picture plane and in depth, so either 2 or 3 dimensions. But the more they had to rotate it, the longer it took them to make that decision. So you could see on the top figure here, that might be, 90 degrees of rotation going from right to left. On letter B, a whole lot more than that, actually, maybe 270, and on letter C, less. And depending on how much rotation there was to be done, their particular results suggested that it took that much longer to make the decision of yes or no that they matched. A very clever experiment. And the participant's job was rather simple. Do they match? So there was a similar experiment with that having to do with letters that your author described. That's Cooper and Shepard, same author, of course. So here's an explanation. Cooper found that the reaction times once again increased linearly with the angle of rotation, and that the rate of rotation was the same for all polygons, regardless of their complexity. And he's referring to polygons down here. You could see that some are rather complex, some are simpler. If participants were attending to only parts of the polygons, then performance should have differed as a function of the polygon complexity, but it does appear that participants mentally rotated the entire thing. So instead of these somewhat simple examples, we've got ones that are much more intricate with a lot more angles, but the participants apparently took the entire image and rotated it. So a suggestion here is that the imagined process of rotating an image is the same as actually physically rotating it, if you will. The imagination is analogous or is an analog to the actual physical process of rotating it, and thus it takes longer to answer a basic question such as whether they're the same figure flipped or rotated or what have you. So this was an early suggestion, and again, it's, as you can see, nearly 50 years old, or more than 50 years old in Shepard and Metzler's case, that we engage in a process in visualizing that's almost the same as physically manipulating it. Fairly clever. And again, this is one of those sorts of things that is not really expanded on much since, but it is a bit of a foundation for all of cognitive psychology.